Okay, everybody, today we're going to continue with probability. So, last time we talked about conditional probability, and that was basically the probability that something would happen if I already knew something else happened. All right, that was conditional. It's conditional on something previously happening. All right, today we're going to talk about something called the multiplication rule. And this is also known as the AND rule. So basically, it's the probability that something and something else will happen. So let's say this is the probability, I don't want that bolded, that two events, A and B, will occur in sequence U. Is we call it, we say the probability of A and B. And what the probability of A and B is, it's, if you remember from our, when we did our possible combinations, we're going to be multiplying. Now, the tricky thing here is that the probability that A and B is going to occur is the probability of A times the probability of B given A, right? So that sounds a little confusing, but when you think about it logically, it makes sense. So the probability of A, and then what we're doing is we're saying A already occurred. So what's the probability of A after I know, or excuse me, the probability of B after I already know that A occurred? So that's where the second part, probability of B given A, is. Another note about the multiplication rule is if the events A and B are independent, then I don't need to care about that given thing because the given won't even matter. And we just multiply them. Okay, hope that makes sense. We're going to do a bunch of examples because this can be a little confusing. So we're going to kind of rip through more examples than we normally would. All right, so two cards are selected without replacement from a standard deck. Remember, there's 52 cards in a deck of cards. What's the probability of selecting a king, then selecting a queen? There are 4 kings in a deck, so the probability here, I don't know why it always does that, centers it. The probability of getting that king, excuse me, is 4 out of 52. And then selecting a queen. So we're doing the probability of B given A. So we already got that king. It says without replacement, so we're not putting the king back. So there are 4 queens left, and there are only 51 cards left. So that gives us 16 over 2,652, which is 0.006. All right, so this was our probability of the first event occurring. This was the probability of getting that queen. Given we already got the king, the given basically took one away from the denominator here. So we have a probability of a king then a queen of 0.006. All right, if we didn't say the without replacement and I shuffled that king back in the deck again, then those would be independent. It'd just be 4 out of 52 times 4 out of 52. All right, let's look at some independent events now. A coin is tossed and a die is rolled. All right, so that means we're going to flip a coin, and we are also going to roll a die. So we want to find the probability of heads and a 6. These are independent events. It does not matter what I get on the coin as to what happens when I roll the die. So the probability of heads is just a half. No idea why this is so much smaller. And then the probability of rolling a 6 is 1/6, which gives me a probability of 1/12, and 1/12 is 0.083. Zero in there, so we'll mess that up. All right, so this is an example of independent events. All right, let's look at the salmon. All right, Fiji. Probability that salmon swims successfully through a dam is 0.85. So what's the probability that 3 salmon successfully swim through the dam? So I'm just going to use S for success and F for failure. So the probability of success, that's just 0.85 times 0.85 times 0.85. It doesn't matter if the first salmon gets through. That doesn't affect the second salmon getting through at all. So we have 0.85 times 0.85 times 0.85, which is 0.614. All right, what's the probability that none of the 3 salmon is successful? Now, this is kind of interesting. So that's failure. So the probability of, if the probability of success is 0.85, then I can just say the probability of failure is 1 minus 0.85, which is 0.15. So failure, 0.15, failure, 0.15, failure, 0.15. And that is 0.003. All right, pretty interesting. That's called a complement. Basically, the complement of success is failure, because when you add them together, it gets you 1. What's the probability that at least one of the salmon is successful? Now, we can do this a couple ways. The harder way would be to find the probability of 1 salmon being successful, and then the probability of 2 salmon being successful, and then the probability of 3 salmon being successful, which we already found. But if we already know none, at least 1 is everything but none. So probability all we have to do is say the only thing that is not at least 1 being successful is none being successful. So we can just take this 0.003 away from 1, which is 0.997. All right, let's do one more quick problem. 12 light bulbs are tested to see if they last as long as the manufacturer claims they do. 3 fail. All right, so it's 3 fail out of 12, 9 pass out of 12. So that means the probability of a failure is 3 out of 12, and the probability of success is 9 out of 12. So let's find the probability that both light bulbs fail. All right, so now this one's kind of a little bit more interesting. So the probability that both fail. So the first one fails. To our notation. Probability of fail, fail. 3 out of 12 that the first one fails times now notice if they both fail, then there's only 2 that fail left, and there's only 11 total failures left. So that gives me a probability of 6 out of 132, which is 0.045. So again, this is 2 out of 11 for the second failure because there's only 2 failing light bulbs left and there's only 11 total light bulbs left. Find the probability that they both pass. All right, our pass was 9 out of 12 times. Now there's only 8 passing light bulbs left out of 11 total light bulbs left. That's 72 out of 132, which is 0.545. Again, remember your probability needs to be between 0 and 1. If you get a negative number or if you get a number larger than 1, then that doesn't make sense. Again, find the probability that one light bulb failed the test. All right, so with 2 light bulbs being selected, our only 3 options are both fail, both pass, and then 1 fails or 1 passes. So probability that 1 passes, since these are our 2 other options, I can just do 1 minus 0.545 minus 0.045. And what's left? That's 0.419. All right. Hopefully this was helpful for you. I'm going to do another assignment out of the textbook. It's just about 5 problems, a couple with multiple parts like 3 and 4 that we just did. Feel free to ask me questions if you have them, and have a wonderful second to last week of instruction. Peace.